Welcome to this explainer. Today, we are demystifying a concept that is absolutely the bedrock of modern cybersecurity. We're going to look at how the everyday web technologies that builds the internet are, ironically, the exact same surfaces targeted by malicious actors. Because, think about it, to stop an attacker, you have to know exactly what they're looking at. We constantly see these massive, alarming headlines about corporate data breaches, right? But it really makes you wonder, how do attackers actually slip through the cracks of the everyday websites we all use? Well, they aren't just sitting there guessing passwords all day. They are actively manipulating the underlying code that makes a website function. Let's ground this with something super familiar. Take the fictional TM Techwork shopping cart. It looks completely normal. You've got products, prices, and add to cart button. But underneath this simple storefront is a seriously complex ecosystem. We're going to use this site to track how your data actually journeys through an app, and more importantly, where the hidden dangers lie. To truly understand web security, we're doing a full anatomical deconstruction today. We'll cover HTML, the web skeleton, CSS, styling and spoofing, JavaScript, interactivity and exploits, SQL, defending the database, and finally, we'll pull it all together with the cybersecurity big picture.
All right, let's start with Section 1, HTML, the web skeleton.
It's actually fascinating to think about HTML as the literal skeleton of a website. It defines absolutely everything structural. You have the document object model, or DOM, which maps out exactly how elements are nested inside one another, from the head right down to the body. It structures everything, including those login forms we type our passwords into every single day. And that exposes a major vulnerability. See, a normal user just sees a harmless, standard login box. But an attacker, they are analyzing the underlying source code to see the unfiltered truth. They're actively hunting for hidden inputs, maybe forgotten developer comments, or exposed administrative paths. If sensitive structural data is left sitting in the HTML, attackers can often manipulate it right there in their browser. Moving on to Section 2, CSS, styling and spoofing. Now, CSS is fantastic. Without it, let's be honest, every web page would look like a boring plain text document from 1995, or maybe a ransom note. CSS controls the colors, the fonts, and creates those beautiful, responsive layouts that adapt perfectly whether you're swiping on a phone, tapping a tablet, or sitting at a massive desktop monitor. But there is definitely a dark side to CSS, and that's UI spoofing. Because CSS dictates exactly how things look, attackers can use it to perfectly clone the layout of a legitimate platform. I'm talking about your bank, Apple, Microsoft, PayPal, you name it. They build these highly convincing phishing pages that look absolutely identical to the real thing, all to steal your credentials. So cybersecurity analysts have to deeply examine CSS to detect these clone sites, and also to spot hidden elements. Sometimes, a developer will try to hide an admin button just by setting the CSS display to none, instead of actually securing it properly. Next up, Section 3, JavaScript, interactivity, and exploits. JavaScript is the muscle. It's what makes a website actually do things without reloading the page. Stuff like validating your password length or calculating the total in that shopping cart. But here is the critical security catch. JavaScript usually runs client-side. That means it runs right in the user's browser. Anyone can just hit F12, open up the developer tools, and manipulate it. Because of this, client-side JavaScript can never, ever be fully trusted for security validation. An attacker can literally just disable a check before sending their data to the server. And this leads us to one of the most notorious web vulnerabilities out there, cross-site scripting, or XSS for short. This happens when a website takes user input, let's say a product review, and displays it without sanitizing it first. If an attacker drops a malicious script into that box instead of a review, the next victim's browser will blindly execute it simply because it assumes the website told it to. Once that malicious script executes on the victim's machine, the damage can be severe. Attackers use XSS to manipulate the DOM, bypass security restrictions, and most dangerously, steal highly sensitive data directly from the user's cookies. We're talking siphoning off session IDs and login tokens, which allows them to completely hijack your logged-in session, no password required. This is exactly why secure systems implement HTTP-only attributes on cookies, which ensures that client-side JavaScript absolutely cannot read them. Down into the vault we go with Section 4, SQL, defending the database. While HTML, CSS, and JavaScript handle the user's end of things, SQL is the language communicating with the actual databases back on the server.
Almost every website stores its critical information in these relational databases. This is where the crown jewels live, folks. User accounts, password hashes, product inventories, customer orders. It is the ultimate jackpot for any attacker. So let's talk about one of the oldest yet still most devastating attacks, SQL injection. If an application takes what a user types into a login box and just pastes it directly into a database query without checking it, disaster strikes. By inserting a specific string of characters, an attacker can trick the database into evaluating a statement that is mathematically always true, like 1 = 1. This incredibly simple logic trick can bypass a login screen entirely or literally leak an entire customer database in seconds.
To defend the vault against these injection attacks, cybersecurity professionals have to insist on a few absolute necessities. First, developers must use parameterized queries, also known as prepared statements, so the database explicitly knows what is actual code and what is just user input. On top of that, teams must validate all inputs, ensure database accounts operate on a strict least privilege basis, and carefully configure error handling. You definitely don't want an error message accidentally revealing your underlying database structure to an attacker who is probing the system.
Bringing it all together in Section 5, the cybersecurity big picture.
Let's trace how all these individual pieces build a complete data journey. It starts with your browser requesting a page. The server sends back the HTML for the structure and the CSS for the style. Then JavaScript steps in to handle immediate client-side interactions. When you finally click checkout, that request travels all the way back to the server, which securely uses SQL to update the database vault. It's a living, breathing ecosystem.
Think of this matrix as your ultimate cheat sheet. It perfectly maps every foundational technology we just talked about to its common risks and defenses. HTML risks exposed forms. You defend that with secure coding. CSS risks UI spoofing. Mitigate that with user education and careful analysis. JavaScript brings the threat of XSS. Fight it with input sanitization. And SQL brings those massive injection threats, which you defend against by using prepared statements.
So why does all of this actually matter to you? Well, getting hands-on experience with these tools is what allows security analysts, penetration testers, and AppSec engineers to identify vulnerabilities long before an attacker can exploit them. By understanding exactly how a developer builds a site, you can effectively read the source code, protect the databases, and crucially, you can communicate effectively with those developers during security reviews to actually fix the issues. To wrap up this explainer, I want to leave you with a provocative thought for your own cybersecurity journey. You absolutely cannot secure a system that you do not fundamentally understand. So which of these 4 foundational web technologies, HTML, CSS, JavaScript, or SQL, will you choose to master first? The internet's security depends on the people who know exactly how it's built.